The last part here is the strength of acids and bases. And the strength of bases, acids and bases is going to follow you everywhere, so might as well learn it properly. The question here is, which is the stronger acid in the following pairs? Okay, so you have two things given to you, sulfuric acid H2SO4 and H2SO3. Without doing detailed work, you can see that H2SO4 is going to be stronger. Why? Because, yes, it has more oxygen. More oxygen means more electronegativity. More electronegativity means that you will have weaker bonds. Let me go ahead and draw the structure out for you so you can see what it means. Okay, so sulfuric acid has a Lewis structure of where you have sulfur in the middle, and you should have 4 bonds for oxygen. Okay, and then you have 2 hydrogens. In acids, you will always have the hydrogen bonded to the oxygens. Okay, always. That's the main thing about acids. And then, well, you can have it to sulfur also, okay, but it's going to be a different acidity. But when there is an option, the acidic proton is going to be on the oxygen. So which means the other 2 oxygens here are going to be your double bonded ones. And if you were to fill out the lone pair of electrons, this is what it would be. But anyhow, what we are saying over here is that you have 1, 2, 3, 4 oxygens here. And so the proton here is very easy for it to go away because of all the electronegativity. The other structure is again sulfur in the middle. This is sulfurous acid, sulfur in the middle, but now you have 3 oxygens. So here are the 3 oxygens, okay, and then you have 1 hydrogen connected over here. And how do I know to draw this Lewis structure? It's because sulfur can have an expanded shell, okay, that's why it has more than 4 bonds. So if you just have the 4 bonds, and the oxygens are not going to be happy, okay, and so sulfur can either have 2 bonds or it can have 6 bonds, it can have 4 also, but everything else has to be happy as well. But anyhow, in this case, oxygen will not be happy if we just had the 4 bonds or the 2 bonds. Okay, so there are 2 hydrogens in sulfurous acid, so 1 hydrogen is going to be bonded to sulfur and 1 hydrogen is going to be bonded to the oxygen over here. Again, fulfilling my lone pair requirement, this is what it is. So now I can clearly see that I have 2 different kinds of protons here, what I was talking to you about before. The hydrogen here is connected to sulfur, the hydrogen here is connected to oxygen. So if you were to be asked which hydrogen is going to go away first, it's going to be this one. This is the acidic proton, okay? This is not acidic, okay? And again, because the hydrogen-sulfur bond is not as polar as the oxygen-hydrogen bond. This is more polar, so it's easier for this bond to break and therefore for the hydrogen to go away. So this is the acidic proton. But the other part of this whole thing was, of course, the sulfuric acid versus sulfurous acid. So sulfuric acid has more oxygens and therefore it's a stronger acid. Okay, so that's our logistics behind that. Now let's look at the next one where you have an organic acid. So you have the carbons in there. And so as soon as you have carbons in there, then we have to look at a different way. And I'm missing a carbon here. There. This is also all about electronegativity. Okay, it's about electronegativity and it's about what we call inductive effect. And inductive effect, remember, is the pull or push of electrons over a few bonds. We're like about 2 bonds or 3 bonds. It's not about 4 or 5 bonds. Okay, so that's inductive effect. And inductive effect is as a result of pulling or pushing electron. The pulling of electron comes from electronegativity. So if there is something more electronegative, it will pull electrons towards itself. Where if we look over here, then we have 3 chlorines pulling electrons towards itself and only 1 bromine over here pulling electrons towards itself. So therefore, this is the stronger acid. Even if you had 3 bromines over here, this one would still be the stronger acid because chlorine is more electronegative than bromine. Okay, so as it is poor, this acid has no chance whatsoever. Okay, the next one here then is H2SE and H2TE. Okay, these are just 2 acids. Not very common acids, obviously. So this is just a test about if you understand acidity and basicity. Okay, and so all you're looking for in this case is the size of the atom, because both Se and Te, selenium and tellurium, they belong to the same group. So you're looking for the stronger acid here. So the stronger acid here would be the difference only in the atomic size. It's really a good idea to get to the bottom of things and understand why things are happening instead of just memorizing it, because once you understand why things are happening, it will be easier for you to make these predictions. So here the reason is atomic size. Okay, and so atomic size is larger for tellurium, and remember, if tellurium is larger in size, it cannot hold on to the hydrogen, so it will be easily ionized. Whereas in this case with the selenium, the hydrogen is tightly bound to the selenium because they are a little bit, the selenium is smaller in size, so it can hold on to the hydrogen, but tellurium cannot hold on to hydrogens. So hydrogens will float away, they will be easily ionized, okay? And this was because of atomic size. So we've taken three different categories here. The first one was the number of oxygen, also has to do with electronegativity, but number of oxygen was the easy way over here. This was inductive effect, electronegativity, and this was atomic size. Okay, now here's the last one, and I'll give you 10 seconds to figure out what we're going to use over here. Yep, we're going to use inductive effect, okay, for this one, because you're talking about an organic acid. It's a really long acid. So here we have bromine, which is really close to the acidic proton. And how do you know this is the acidic proton, by the way? Again, because it is bonded to the oxygen. That is how you know that this is the acidic proton. So the bromine is closer to the acidic proton, and therefore this becomes the stronger acid. Chlorine here is very far away from the acidic proton. So even though it's stronger, in electronegativity, it's not going to have that much effect, okay, because it's too far away from the acidic proton. Remember, in organic compounds like this one, you have like so many hydrogens, so it's really important for you to know what is the acidic proton. So always remember, the acidic proton is going to be the one connected to oxygen or the more electronegative element. Okay, that's how you figure out. Okay, so then the next question is, what is a stronger base? Usually you don't find these questions, and I like to do them because they're the opposite of acids. Most people focus on acids, but I like to focus on bases also, just to make sure you've understood the concept. So the first one is water versus hydroxide. Now here our reasoning is going to be very simple. Okay, here if you have a negative species, a negative ion versus neutral, and the negative ion is always going to be a stronger base. Okay, that's all it is. Bases are all about giving electrons. Okay, so the more electrons there are to give, the stronger the base would be also. So this is going to be stronger. Hydroxide, as it is a basic thing anyway. Okay, so water is amphoteric, it can be acidic or base, but hydroxide, as you know, are all bases. Okay, so this is a stronger base then. But then the other thing is, the main thing that I mentioned here is that it's also because of negative ions. So then let's look at the next one here, which is Cl, CH2, NH2, CH3, NH2. Okay, so here you have a chlorine, but in the second compound there is no chlorine. Now remember, chlorine is an electronegative. Okay, if it's an electronegative substance or element, excuse me, then you're looking at two things. You're just comparing electronegativity, or you're comparing inductive effect. Again, remember, bases are all about giving electrons. Okay, so if chlorine is pulling electrons away, then nitrogen, which has the lone pair of electrons, is not capable of giving electrons away. All right, so which means that the one without the chlorine is a stronger base then. Okay, again, why? Because nitrogen is the one that has the lone pair of electrons. It has to give these electrons away. So if chlorine is pulling the electrons away from nitrogen, then nitrogen cannot give the electrons. Okay, so this is weaker, and the one without the chlorine is stronger. So this was because of inductive effect. The last one here is sodium hydroxide versus CH3, CH2, NH2. Wherever you see a lot of carbons, that means that something is organic in nature. And NaOH, sodium hydroxide, you already know this is what we call mineral bases. Okay, so like a mineral acid would be sulfuric acid. So as soon as you have a mineral versus organic, mineral is always going to be stronger. Okay, you can close your eyes and decide that. Okay, so another example, let me just give you real quickly, is H2SO4 versus say acetic acid. Okay, so again this is organic because you have the carbons in here, and this is sulfuric acid, this is mineral, and so if this is a mineral acid, this is going to be a stronger one. Let me give you another example of another base. So CH3 NH2 versus CH3 NH minus. So if you were comparing these two, then hands down this is going to be stronger because this is negatively charged. Okay, and so keep it simple for yourself, okay, and know exactly why you are answering the question, because everything has a logic behind it.